Hi everyone, I'm Cheryl. In this problem, we're asked to find a power series for my function g of x equals 4x all over x squared plus 2x minus 3 centered at 0. All right, now to help us get a power series, I want to make use of the fact that a geometric series is a power series. And the geometric series from 0 to infinity of a times r to the n is going to equal a divided by 1 minus r when it converges. So what I want to do is I want to try to somehow figure out how to write my function g in the form a divided by 1 minus r. Because if I can do that, I can convert it over into this series type of notation. All right, so let's take a look at how I'm going to do that. I'll need to use a process called partial fractions. So I'll begin by taking my function g and noticing that that denominator factors. So I'll write it as 4x divided by the quantity x plus 3 times the quantity x minus 1. And then, by partial fractions, I know that this can be written as some constant divided by x plus 3 plus some other constant divided by x minus 1. I'll take both sides of this equation and multiply it by the quantity x plus 3, x minus 1. And when I do that, I end up with a 4x on the left-hand side. And on the right-hand side, I have a times the quantity x minus 1 plus b times the quantity x plus 3. Distributing the a and the b, I get 4x equals ax minus a plus bx plus 3b. I'm going to collect my x terms together and my constant terms together. So I have 4x equals the quantity a plus b times x because I have two x terms. And I have a negative a plus 3b as my constant terms. Well, what does this tell me? Well, I know then that a plus b, the x term on the right-hand side, has to be the same as the x term on the left-hand side. So a plus b must equal 4. And the constant term on the right-hand side must be the same as the constant term on the left-hand side. So minus a plus 3b must equal 0 because there is no constant term on the left-hand side. This gives me a system of equations. And that system of equations tells me that 4b is going to equal 4, which means that b equals 1. And if b equals 1, I know that a plus b equals 4, so a plus 1 equals 4, and a is going to equal 3. So what does that tell me? Well, it tells me that my original function g of x can be written as a, which is going to be 3, divided by x plus 3, and I'll be adding 1 divided by x minus 1. Okay, so now I have a function that has two separate parts, but those parts are looking closer to this a divided by 1 minus r that I was hoping for. So I'm going to work on this and try to get each of these individual forms to look like a divided by 1 minus r. Okay, now how do I do that? Well, the first thing I notice is that in this format, the constant comes first. So I'm going to rewrite this as 3 divided by 3 plus x plus 1 divided by a minus 1 plus x. I also notice that I would like that first coefficient in the denominator to be a 1. So I'm going to force that to happen by, in that first piece, factoring out a 3. So I'll factor out a 3, and I've got 3 times the quantity, 1 plus 1/3 x. And in a similar way, for this next piece, if I want that first term to be a positive one, I'm going to factor out a minus 1. And when I do that, I'll end up with 1 minus x. Okay, I also notice at this point that this 3 cancels with that one. And so I can rewrite this as 1 divided by 1 plus 1/3 x. And the second part, I'll make this minus 1 over 1 minus x. Okay, I'm getting close. Remember, I want this to be 1 minus r. So I can rewrite this as 1 divided by 1 minus a negative 1/3 x. And the second piece is already set up exactly the way I want it. 1 all over 1 minus x. So in this problem, in this first piece, r is going to be minus 1/3 x. And for the second part, r is just going to be the x. Okay, so now I can rewrite this using this description of my geometric series. So I'm going to have the sum from n equals 0 to infinity of a, which is just a 1, times my r value, which is a minus 1/3 x, raised to the nth power. And for the second series, I'll have the sum n equals 0 to infinity of a, which is 1 in this case, times r, which is x, to the nth power. Okay, so the next thing I'm going to do is clean this piece up just a little bit, and I've got the sum from n equals 0 to infinity, and I can write this as a minus 1/3 to the n, or actually let's just write it as minus 1 to the n all over 3 to the n times x to the n. And then I'll subtract my series from n equals 0 to infinity of x to the n. Finally, as a last step, if you want to, you can combine these two series and write it as the series from n equals 0 to infinity. Notice there's an x to the n in both terms, so I can factor that out, and I've got x to the n times the quantity minus 1 to the n all over 3 to the n minus 1. And so that is my power series. Now, the last piece of this is we need to discuss the interval of convergence. Well, in order to talk about the interval of convergence, I'm going to go back to the spot where I was thinking of these as two separate geometric series. Because if I look at my first geometric series, I'm going to notice that my r value is going to be minus 1/3 x. And I know that my series converges when the absolute value of r is less than 1, which means that the absolute value of x all over 3 must be less than 1, or the absolute value of x has to be less than 3, which means x is going between -3 and +3. For my second series, my r value is going to equal the x. And again, I know this series converges when the absolute value of x is less than 1, which means x is going to bounce between -1 and +1. Now, in order for my original series to converge, both of these conditions have to be true. So my interval of convergence is going to be from -1 to +1, because both of these conditions have to be met. I hope that was helpful. Thanks.